Alright guys, we're going to be talking about the 4 quantum numbers. The quantum numbers are like a zip code or an address for electrons that are flying around the nucleus of the atom. And I like to use chlorine as an example because it's just got this number that's just barely manageable that you can use. Much bigger than this and problems just get too crazy. So anyway, first of all, you got the nucleus, right, which is right in the center here, and then you have all of your energy levels that go around, and this is the planetary model like Bohr. Your first level can only hold 2 electrons. Second level can hold a total of 8. Third is 18. Fourth is 32. Fifth is like 50. And so atoms get bigger and bigger and bigger. Now, what happens here is within each of these levels you have what are called subshells. And you have, for the most part, these 4 subshells. So for the subshells, S, P, D, and F are your subshells that you have. And so these correspond to different shapes, whereby you have all these little areas where the probability that you might find an electron will be greater in certain areas. Let me see if I can make this smaller. So S, P, D, and F correspond to the different orbital shells, and you get all these neat little shapes. Y'all in chemistry know this, but these different shapes just correspond to the different areas where you might find an electron whizzing around the nucleus, and you get all these neat little shapes. And as you go, things get more and more complex. You're cramming more and more stuff in, and so that's a thing. Okay, see if I can make this bigger. Alright, so for chlorine has 17 electrons. Each electron has a specific place where it is and what it's doing and those types of things. Now, for chlorine, these are all the different shells and all the different subshells and all of the electrons. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. All these little numbers correspond to all of the electrons in a subshell. So these little guys are electrons in the subshell. If you add them all up, you'll see that there are in fact 17. All right? Each subshell can hold a different number of electrons. So that's a thing. Now how do I get this 1s2, 2s2, yada yada yada? Should I make this smaller? So for your periodic table, here's our periodic table, right? Chlorine is right there. Whoops. Chlorine's right here. Okay. So this first row up here, this is row 1, and you get row 2. So starting with hydrogen is row 1. And then lithium is row 2. And then starting with sodium is row 3. So that's corresponding to the energy levels, right? And if I click on this one, you'll see row 1, row 2, row 3, row 4. Okay. Now, these first 2 columns here, those are your those are your S's, excuse me. And then this rectangle right here, those are your D's. This big square right here, those are the P's. And then that group down at the bottom would be the F's. Let's see, I click on this one. I don't like that one as much. All right? So you have, these are your S's, those are your D's, here are your P's, they're the F's. Okay? So, hydrogen is 1s1, helium is 1s2. Then you go right here next to lithium is 2s1. This is 2s2. And these are your P's, 2p1, 2p2, 3, 4, 5, and 6. And then you go down here, 3s1, 3s2, 3p1, 3p2, 3p3, 4, 5, 6, and it just keeps going like that. Now at some point the D's start to overlap the P's and it gets a little nutty. So for chlorine is 1s2, 2s2, 2p6, 3s2, 3p1, 2, 3, 4, and 5. So there you are, right? Let's see if I make this bigger. Exactly what I showed you here, all the way up to 3p5. Okay? And so you may or may not have to do this. I haven't seen a lot of problems make you do these things, but it's possible. So I wanted to show you that, and really it's a blast from the past as far as chemistry goes. All right, so as far as chlorine goes, each one of those electrons has a particular thing, place that it's, there, that it's doing. And so how do you figure this out for each one? All right, hopefully that's big. So the 4 quantum numbers are N, L, M sub L, and M sub S. N is your energy level, or the shell. Ring 1, ring 2, ring 3, ring 4, L is the orbital number, or the subshell. L goes from 0 all the way up to N minus 1. So if my N is 1, then my L will be 0, because it's going to be 1 minus 1, which is 0. So the second number depends on the first one, and the third number depends on the second one. So you have to keep track as you go. The third is M sub L, which is called the magnetic number, and it goes from negative L all the way up to positive L. So you have to keep track of what L is. And then the fourth number is something called spin. Now a lot of this has to do with how electrons are impacted by external magnetic fields. Electrons are whizzing around and they're moving, and electrons are one of those strange things. They're both particles and waves, and so there's a lot of strangeness, and they have angular momentum, and they're just doing a lot of things. Do they spin? This is more of an analogy, really. Electrons are quantized particles. They have like a magnetic moment. And so they're all negative, so they want to be away from each other, and they're just doing a lot of things. And so these 4 numbers are supposed to help you figure out where they are, what are they doing, kind of a categorization, if you will. And so I'm going to show you how to do this. I think we'll use chlorine. All right, see if I can make this bigger, I hope. So here's how I do this. This is what I call the hotel analogy. When I'm wanting to know how many electrons are in each shell, what are they doing, how do I use all these quantum numbers. Problems I've seen involve the quantum numbers, but making a chart will help you through this. So we're going to use chlorine. Chlorine has 17 electrons that we have to fill. So the whole idea here is, you are managing a hotel, and you have to fill guests from the bottom floor first. So we're going to start with our first energy level, which is like that first ring, right? And so N is 1. L goes all the way up to N minus 1. So if my N is 1, then 1 minus 1 will be 0. That corresponds to the S subshell. Now, M sub L is from negative L all the way up to positive L, which would be negative 0 all the way up to positive 0, which is just 0. Okay? Now, this means if we just have zeros here, we have one energy level with just these zeros, that means there is essentially one room that electrons can fill. And we'll have 2 electrons. One has a positive spin, one has negative spin. So that means one has an up arrow and the other has a down. And that's how that works. And if you remember, for an energy level of 1, the maximum can have 2 electrons, max. Okay? Okay. Now, we have 2 of our 17 done. So we have 15 more. So here we go. Energy level 2. That would be that second ring, right? So for 2, L goes from 0 all the way up to N minus 1. So now we're going to have 0, which is our S shell. All right. And then m sub L is from negative L to L, so if our L is 0, then that's negative 0 to positive 0, that's just 0, and there's another room. I can fill electrons in. Now, so this is an n of 2, right? So L goes from 0 all the way up to n minus 1. So 2 minus 1 would be 1. That corresponds to a p subshell. So if our L goes all the way up to 1, then that means for m sub L, it's negative 1 all the way up to positive 1. So that would be negative 1, and then that would be going from negative 1 or negative L to positive L. So negative 1, 0, positive 1. And those are 3 more rooms that we can fill up. If you guys remember, in the 2 energy level, the second, you can have a maximum of 8 electrons. Since we have 15 total, we're going to put 2 in every room. And there's our 8 total. So now we have 10 total. 8 plus 2 is 10. We have 7 more, which means we have 7 more to fill, so we have to go all the way up to the 3rd energy level. So for the 3rd, you're going to have a 0. You're going to have a 1. Just 3 more rooms. And then it goes all the way up to n minus 1, right? So 3 minus 1 is 2, so now we're going to have a 2 here. And this gets a little crazy because now it's going to go from negative 2 all the way up to positive 2. I got to erase some of this so I can cram all this in, right? So this is going to go from negative 2, negative 1, 0, 1, 2. You see what happens. See what I mean? You know, chlorine is a good example because it just gets too crazy too fast, you know. And so what happens is, how many more we have? 8 plus 2 is 10. We have 7 more, right? So I can put 2 in this first room, put 2 in this second room, and put 2 in this third room, and then I have 1 left over. That's for my 7. Remember that in this 3rd energy level, you have a total of 18 electrons max that you can put in, right? 2, 4, 6, 8, 10, 12, 14, 16, 18. So anyway, atoms much bigger than this, gets a little crazy, and if you're doing like a multiple choice problem, it just is just too much. But this is an example of what you would see. All right, last thing. Let's see if I can make this a little bit bigger. So here's an example that I would give y'all. So for some atom, let's say that that L, right, which is our orbital number, our subshell number is 7, right? Then how many orbital magnetic quantum numbers are there allowed if L is 7, right? So what we're looking for is how many m sub L's, right? So if L is 7, if you remember, m sub L goes from negative L all the way to negative 1, 0, positive 1, to positive L, right? That's the rule. So if m sub L, if L is 7, then that would go from negative 7 all the way up to positive 7, negative 7, negative 6, negative 5. And you get all those numbers. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the answer would be 15 total orbital magnetic quantum numbers.